Welcome to this episode of Robert's Creative Chronicles. So today we'll be solving this question, which states that show that the following equation is exact and find u such that the u is a total differential. Here is the equation. So solution. An exact differential equation is any equation of the form m xy dx plus n xy dy is equals to 0. So any equation of this form is called an exact differential equation, where this can also be written as m dx plus n dy is equals to 0. So this equation can also be written as this. This is trying to tell you that this m and n are functions in terms of x and y. But sometimes m can only be a function of y and n can only be a function of x, or vice versa. So it depends, but this is trying to tell you that there can be a function of x. M and n can be a function of x and y, or a function of one of them. So where for this to be an exact equation, the partial derivative of m with respect to what? With respect to the partial derivative of m with respect to y must be equal to the partial derivative of n with respect to x. So this must be satisfied before this is an exact differential equation. So this is the exact differential equation, and this condition must be satisfied before it becomes an exact differential equation. So now let's compare this equation and this one. The coefficient of the x here is m, and the coefficient of the y here is n. So now this one is the coefficient of the x, so this is our m. So you will say m is equal to this 2xy minus 3x squared. This is our m. And then n now is the coefficient of the y. So n is what? N is x squared plus 2y. So n is what? X squared plus 2y. Then we can find the partial derivative of m with respect to y. So the partial derivative of m with respect to y is what? Now, in partial derivative, we are going to differentiate all the functions of y here, while treating all the functions of x as a constant. So anywhere we see x, we treat it as a constant, and you know that the derivative of a constant is 0. So now y will be a variable, x will be a constant in the partial derivative of m with respect to y. So here this becomes x is a constant, 2x is a constant, so it becomes 2. The derivative of 2xy is what? Is 2x, because the derivative of y is 1. So this is 2x. And in this one, since it's partial derivative, there's no writing the y over the x when you differentiate y, like implicit differentiation. No. You do it. You don't need to write y. You want to attach the y there over the x to y. So this becomes, then this is minus, the derivative of this is a constant, so it's 0. Then the second one, partial derivative of n with respect to what? To x. We will treat y as a constant here. So the partial derivative of x squared is what? Is 2x. Derivative of 2y is 0. So here, this one is equal to this. So this condition is satisfied. So we can say that, we can write that the m over the y is equals to the n over the x, which is equals to 2x. So hence, you can say that hence, the equation is exact. So with this equation is exact, because it has satisfied this condition. So now, So now we will let u be a function such that this u be a function such that the partial derivative of u with respect to x equals to m, and the partial derivative of u with respect to y is equals to n. So since the u over the x is m, we can substitute it here. So it will be what? The u over the x, this is m, so it will be 2xy minus 3x squared. And also here, the u over the y is equals to what? Is equals to n. Here is n, x squared plus 2y. So now this will be our equation 1, and this will be our equation 2. So now we can start. From this step, there are two ways you can solve this exact differential equation from this step. You either use equation 1 or use equation 2. So I will start by using equation 2. Then in the other step, I'll use equation 1. So I'll show you the two ways. You can either use any equation you want. You can either use equation 1 or 2, depending on the one you want. So let's use equation 2. So we will say we'll integrate equation 2 with respect to the y. So it will be integrate. But first, let me draw a border. So I'll show you the two methods. So now I'll integrate equation 2 with respect to the y. Let me write it. Integrate equation 2. This equation 2 with respect to the y. Since I'm integrating equation 2, I'll integrate it with respect to the y, so that we can find the answer, because here is already the y, so I'll integrate with respect to the y. So since we are using equation 2, we'll say integrate. So we'll integrate equation 2 with respect to the y now. So it will be integral of the u over the x, the u over the y, then the y. Since we are integrating with respect to the y, we'll add the y to both sides. So it will be equals to integral of x squared plus 2y dy. So now this becomes u. This left hand side becomes u because of this integral and this derivative. So then this side, now this one, you can open the bracket first. You open the bracket, say integral of x squared dy. So the integral of x squared dy is what? In this one, we are going to treat, since we are integrating with respect to dy, we are going to treat x as a constant, like we do in partial differentiation. So this x squared now will become a constant. So I can do it. Let me open the bracket so you see x squared dy plus 2y dy. So now this one will be treated as a constant. So I'll factor x squared out. It will be integral of dy. So it will be integral of dy is what? Is y. So it will be x squared y plus this one. I'll factor the constant 2 out. But since it's with respect to the y, I cannot factor y because y is the variable we are integrating. So it will be 2y squared over 2. So 2 will cancel 2, so it becomes y squared. Then we'll add the constant of integration. Since we are integrating with respect to the y now, the constant we're going to use is tx. If we were integrating with respect to the x, we're going to use ty here. But since we are integrating with respect to the y, we are going to use tx here. So now this becomes our equation 3. So this is the value for u. So now we are going to differentiate this equation u with respect to x, so that we can equate it to this equation 1. So we'll differentiate it, but we'll find the partial derivative of u. So now we'll find the partial derivative of u with respect to x. So we'll write differentiate equation 3 with respect to what? To x. So we'll differentiate this equation 3 with respect to x, so that we can equate it to this equation 1. So it will be the partial derivative. So it will be partial derivative of u with respect to x. So now we are finding, that means x is a constant now, while we are treating y as a variable, since it's partial differentiation. This will be what? We are integrating x, so y is a constant, so it will be what? 2xy. This derivative of y is 0, since it is a constant here, since it's partial derivative of u with respect to x. Then this one will be what? T prime x. That is the derivative. To show the derivative of tx is t prime x, the first derivative. So this now becomes equation 4. Now we are going to equate this one, equation 1. Now we are going to equate equation 1 and 4, because this is the same partial derivative of u with respect to x. So we are going to equate these two terms. So now we will have 2x, that is, we'll say equating, let me write it here first. Equating equation 1 and 4. So it will be 2xy plus t prime x is equals to 2xy minus 3x squared. It's equals to 2xy minus 3x squared. So now this will move here. It will become 2xy minus 2xy is what is 0. So t prime x is what? Is minus 3x squared, because this and this will cancel each other. So this becomes our equation 5. Now we will integrate this equation with respect to dx. Now we will integrate this equation 5 with respect to dx. So I'll write integrate equation 5 with respect to dx, so that we will get tx. And when we get tx, we'll substitute it in this equation, because this is the equation we want to find the value for. We want to find tx now in this equation 3. So if we integrate this equation, we will find tx. So this t prime will become tx. This t prime will become t. So now we integrate this, it becomes t prime x dx is equals to what? Integral of minus 3x squared dx. So integral of this is what? Is tx. Is equals to what? Now, since the integral is with respect to dx and this is x, so it will be minus 3x cubed over 3. So 3 will cancel 3 to be minus x cubed. So this is minus x cubed. This is minus x cubed. Then we'll add the constant of integration, which is plus c. So this is the final thing we are going to integrate. So this becomes our equation 6. So now we can substitute equation 6 back into this equation 3 to get u. So now we have found tx here. So we can substitute equation 6 back into 3 to get u. So I'll say substitute equation 6 into what? Into 3. So this becomes what? So u now becomes u is equals to x square y plus y square plus what? Plus minus x cube plus c. Plus minus x cube plus c. Then u now is equals to what? X square y plus y square minus x cube plus c. So this is the value for u. So we have gotten the value for u, and this is the final answer. Now, if you imagine you wanted to use equation 1 now, it will be integrate equation 1 with respect to the x. Instead of the y, to be integrating, we will be integrating. Let me show the alternative method. So alternative method. This is the alternative method. Now, this one, we use equation 2. We use the equation 2 to solve this differential equation. Now we can also use equation 1. Now we will integrate equation 1 with respect to the x now. So it will be what? Integral of u over the x is equal to integral of what? 2xy minus 3x squared dx. So now this becomes u is equals to, we integrate this with respect to the x, that means y is a constant. We'll treat it as a constant. So now this becomes what? We will factor out, you can open the bracket like I did here, but since we have already done it here, I can directly integrate here. So this becomes what? I'll factor out 2y, then to become 2y x squared over 2. So it will be what? Then 2 will cancel 2, so it will be x squared y. Then to be x squared y. Then here we integrate x squared becomes x cubed over 3. So 3 will cancel 3, so it will become minus x cubed. Then we'll add the constant of integration. So instead of, here is tx. Instead of tx here will be ty. Since we are differentiating, since we are integrating with respect to the x, it will be ty. So now here will become my equation 3. This will become my equation 3 instead of this. So then now we will differentiate this equation with respect to y. We will find the partial derivative of u with respect to y. So we can equate it to equation 2 now. Here we differentiated equation 3 with respect to x. So now we are going to differentiate this one with respect to y. So it will be du over dy is equals to what? Here will be, we differentiate y here will be x squared. Here will be 0 plus 3 prime y to show the first derivative. So now this one will be equation 4 instead of this one. So now we are going to equate this equation 4 to this equation 2. Here we equated equation 1 and 4. Here we are going to equate equation 4 to 2 instead of 1. So now du dy, you see du dy. So it will be x squared plus t prime y is equals to what? X squared plus 2y. Plus 2y. So this becomes what? This x squared and this x squared will go, because when this one goes to minus, so it will become 2 prime y is equals to 2y. So this becomes equation 5 instead of this one. So now then we integrate this equation 5 with respect to the y instead of the x. So now we integrate this equation with respect to the y, so it will be like this. Integral of 2y equals to, so the integral of this is y squared over 2, which is y squared, and plus c. So now this becomes equation 6. So now we can substitute equation 6 into equation 3 to replace ty. So now u becomes what? X squared y minus x cubed plus y squared plus c. Now, this is the final answer for this one. Now, check the one we got. This is u is equals to x squared y. This is u is equals to x squared y minus x cubed plus y squared plus c plus c. You can see the answers are the same. So even though you use equation 1 or equation 2, you are going to get the same answer. You just have to know the right one to substitute, or the right one to integrate, and the right one to differentiate. So you have to note all these things down. The one you differentiate with respect to the x or the y, the ones you integrate with respect to the x or with respect to the y, and other things. So that's all about this. So we have successfully showed that this equation is an exact equation, and we have found the value for u such that the u is a total differential. So I hope you understood this episode. If you have any question, feel free to contact me using my WhatsApp or email written in the description below, or you can write them in the comment section. Thank you for watching. Please don't forget to like, share, and subscribe to my channel, and hit the notification bell to get notified as soon as I drop a new video. Thanks.